When you picture a rocket taking off, you're probably imagining a huge fireball shooting into the sky. But have you ever stopped to wonder what exactly that fiery plume is? Is it just a random assortment of smoke and hot gas spewing out of the back of a rocket as it ascends into space? Well, yes and no. You see, that burning question has led scientists and engineers to experiment with various fuels and propellants to find the perfect mix for powering these awe-inspiring machines. So sit tight because today we're going to dive into the nitty-gritty of what actually fuels these technological marvels. All right, now let's talk about the first type of fuel. Liquid fuels. Think of it as the sophisticated choice for rockets. These fuels are stored separately from their oxidizers in dedicated tanks until it's time to launch, once the engines start up. They pump the fuel and oxidizer into the combustion chamber where the magic happens. Liquid fuels offer precise control over the rate of combustion, meaning engineers can easily adjust the thrust of the engine as needed. This flexibility comes in handy during critical maneuvers like landing a rocket or spacecraft. Commonly used liquid fuels include liquid hydrogen and oxygen, which are the go-to for many high-performance rockets. These fuels burn with incredible efficiency, releasing a tremendous amount of energy with relatively small amounts of emissions. In fact, the Apollo program used liquid hydrogen and oxygen to power the Saturn V rocket, which was the most powerful rocket ever built. But it's not all sunshine and rainbows with liquid fuels. As we mentioned earlier, they're stored separately, which adds complexity to the design and increases the risk of leaks. Plus, dealing with cryogenic temperatures can be a pain, requiring specialized equipment and expertise. Despite these challenges, liquid fuels remain the preferred choice for many rocket applications thanks to their versatility and efficiency. Now, let's turn our attention to solid fuels. These bad boys are a more straightforward option. They're simply cast into a solid block and then ignited at the base. Once the fuel starts burning, it continues until the entire charge is expended, meaning there's no need for complex pumping systems or temperature controls. This simplicity translates into cost savings and ease of manufacturing. Solid fuels are also extremely reliable, making them perfect for launch vehicles like the SpaceX Falcon 9. However, they lack the flexibility of liquid fuels since they cannot be throttled or stopped once ignited. Additionally, solid fuels tend to produce lower levels of thrust compared to their liquid counterparts. So, if you're looking for a rocket fuel that packs a serious punch, you might want to stick with liquids. Now, here's a fun fact for you. Did you know that some rocket fuels are actually hypergolic? That means they can ignite spontaneously when two different liquids are mixed together in the right proportion. No ignition source needed. These fuels are typically used in spacecraft engines where reliability is critical. But don't worry, they're not as volatile as they sound. The combination of fuel and oxidizer is stable until it's time to ignite. At that point, the two liquids are pumped into the engine and mixed together, resulting in an immediate and sustained combustion reaction. One common hypergolic fuel is a combination of hydrazine and nitrogen tetroxide. While these fuels are highly effective, they're also extremely toxic, making them a less than ideal choice for large-scale rocket launches. Nevertheless, they remain an important option for powering spacecraft in space where safety is less of a concern. So, which type of fuel reigns supreme in the rocket industry? Well, it depends on the specific application. Liquid fuels offer greater control and efficiency, while solid fuels are simpler and more cost-effective. Ultimately, the best rocket fuel is the one that gets the job done safely and effectively. Now you know the basics of rocket fuel. It's time to put your knowledge to the test. Leave a comment below with your thoughts on the most exciting advancements in rocket technology. Don't forget to subscribe for more videos and leave a like. Thanks for tuning in. See you next time.